Welcome to Xenobiological Structures 201. Today, we begin our detailed analysis of Homo sapiens, commonly referred to as humans or, depending on the galactic region, meat sprinters. The lecturer, Professor Cithril Vox, activated the holo display with a flick of her cilia. A floating, slow-rotating image of a human head shimmered into view, eyes blinking, jaw occasionally twitching. Let us begin, of course, at the top, the head. What appears to be a simple dome of soft tissue conceals a staggering complexity of structure, behavior, and biological systems. The alien student squinted and recoiled as the human head opened its mouth. Yes, Vox continued, you'll note the many orifices. 4, by basic observation, eyes, ears, nose, and mouth. Each one serves a different purpose, and all are exposed to the environment. There is little to no natural armor. And yet, the species thrives. Why would they put their brain casing, arguably their most critical asset, at the front of their bodies? Asked one skeptical student. An excellent question, Professor Vox replied. Apparently, expression, perception, and communication are prioritized over defense. They call this thing, she gestured to the screen as the human grinned, a smile. It is intended to convey non-aggression. However, note the exposure of the teeth, their primary tools for consuming matter. Imagine greeting others by flashing your internal bone plates. A ripple of horror echoed through the class. Professor Cithril Vox gestured toward the rotating holographic projection, now displaying a translucent human head with the skin peeled away. Behold, she said, the skull. A calcified structure composed of 22 separate bones, fused together to protect the species' most prized organ, the brain. A few students recoiled at the image. One clicked their mandibles nervously. 22. Hissed a voice from the back. Why so many? Our species needs only 3. A fair observation, Vox replied smoothly. Humans evolved their skull not as a single protective dome, but as an assembly, each bone with a precise function. The cranium encases the brain, while the facial bones support their complex sensory and digestive openings. With a flick of her wrist, the image zoomed in on the jawbone, then highlighted the eye sockets, the nasal cavity, and the mandible. You'll notice the mandible, or lower jaw, is the only part of the skull that remains mobile. This allows for a range of behaviors, from mastication food consumption, to verbal communication and, on occasion, primitive social mimicry known as karaoke. Murmurs rippled through the class. But Professor, asked a tentacled student named Joran, isn't placing a vital organ inside a fragile dome biological malpractice? Ah, Vox grinned. You think so. Yet the human skull is surprisingly resilient. Compact, layered, and capable of absorbing impact, it provides not only structural support, but a shocking resistance to blunt trauma. Combine that with reflexes, redundant blood pathways, and an overly complex neck joint, and you get, well, this species. The hologram showed a slow-motion video of a human getting hit in the head with a flying object, staggering, then yelling something about, I'm fine. Cithril sighed. And somehow, they are. Professor Vox dimmed the lights. The holo display zoomed in on a pair of unsettlingly human eyes. The pupils adjusted in real time, responding to the ambient lighting in the room. Observe, she said. These are the eyes, a pair of forward-facing, fluid-filled orbs embedded in the human skull. They serve as the species' primary means of perceiving the physical world, and, apparently, of communicating silent judgment. Several students leaned in with fascination, others turned away uncomfortably. Humans possess binocular vision, meaning both eyes focus on the same point. This allows for depth perception, essential for their hunting, throwing, and parkour-based decision-making. Their visual range is limited compared to certain species, but their eyes excel in contrast, color differentiation, and motion tracking. A video played grainy footage of a human catching an object midair, thrown from behind. No formal warning. No anticipatory reflex pattern. Just raw ocular input and absurdly fast reaction. The display shifted to a cross-section of the human eye, cornea, iris, pupil, lens, retina. Do note the complexity. The eye contains over 100 million photoreceptor cells and transmits information through the optic nerve directly to the brain. The system is delicate, yet astonishingly fast. Joran blinked his 3 stalk eyes. What's the dark circle in the center? The pupil, Vox answered. A variable aperture that expands or contracts based on light levels and emotional state. Yes, students, humans visibly leak psychological data through their eyes. The class murmured again. Imagine a creature whose primary sense is openly expressive, easy to misread. invulnerable to something as simple as sand. Professor Vox folded her cilia. Yet they stare. Constantly. Aggressively. And somehow it works. The next slide displayed the sides of the human head, those odd, curved protrusions known as ears. Vox rotated the image, revealing both internal and external structures. The ears, those fleshy cartilaginous spirals on either side of the skull. Despite their soft appearance, these are the entrance ports for one of humanity's most refined senses, hearing. The students leaned forward as the inner ear lit up on the hologram. Externally, they collect sound waves, vibrations in the atmosphere, and funnel them down a narrow canal toward the eardrum. From there, mechanical motion is passed through three minuscule bones, the malleus, incus, and stapes, collectively the smallest bones in the human body. A pause. Cithril let that fact settle in. Yes, bones. Inside the head. Vibrating. To process noise. A few students hissed in disbelief, but this organ doesn't just handle acoustics. No, hidden deeper is the vestibular system, a complex fluid-based structure used for balance and orientation. Humans stand upright, bipedal, and this inner ear fluid sloshing around tells them which way is down. A holovid played, a human spinning in circles and then stumbling around. Of course, the system is delicate. Motion sickness occurs when input becomes inconsistent. And yet, the species uses this flaw recreationally. They build devices to induce nausea, dizziness, and terror, then pay to ride them. An audio clip followed, a human scream mid-roller coaster. Vox sighed. Their ears allow them to perceive symphonies, screams, and sarcasm. But they also betray them to vertigo. A fascinating contradiction. Professor Vox adjusted the hollow projection. The floating human head spun, zooming in on the raised central ridge between the eyes, the nose. Now we come to the nasal organ, the human's primary olfactory intake port. Unlike many galactic species that sense airborne chemicals via skin membranes or specialized antennae, humans rely on this protruding facial feature, known as the nose, to smell their world. A new display showed the internal anatomy, nasal cavity, olfactory receptors, and the sinuses. To the horror of several students, this structure draws in air through dual openings, called nostrils. That air passes over millions of olfactory neurons, receptor cells that identify molecular signatures, commonly referred to as smells. Joran tilted his cranial stalk. But what is the purpose of the slime? Vox smiled grimly. You've noticed the mucus. A moist secretion lining the nasal cavity, used to trap particles, moisten air, and protect internal tissue. It is routinely expelled, sometimes involuntarily, through a violent burst known as a sneeze. She played a video of a human sneezing dramatically in slow motion. Particles erupted like a miniature atmospheric explosion. Note the force, she said. Sneeze velocity averages over 160 kilometers per hour. Another student asked, do they always inhale through this? No, Vox replied. The nose also functions as a backup for breathing. Humans can alternate between mouth and nose as air intake options. Additionally, they link smell and taste neurologically, meaning a blocked nose can impair their food perception. The class fell silent for a moment. Strange, one muttered. They taste, with their scent organ? Vox simply nodded. Indeed, these creatures smell their world, and themselves, with unsettling accuracy. And the holographic projection now zeroed in on the human mouth, closed at first, then slowly opening to reveal the tongue. Teeth and deeper passageways. Welcome, Professor Vox said, to one of the most versatile and biologically absurd features of human anatomy, the mouth. She let the image linger. The students stared at the twin rows of enamel and the pink mass behind them. It is simultaneously a nutrient intake port, an acoustic resonance chamber, and a projectile launch site. It is capable of crafting lullabies, issuing threats, and consuming materials that would be considered corrosive in most species. She highlighted the interior, the lips, tongue, teeth, salivary glands, and the opening of the esophagus. The human mouth can process both solid and liquid substances. The average bite exerts over 500 newtons of force. But that's just the mechanical function. This structure also facilitates the production of language. An audio recording played, a human delivering a rapid-fire motivational speech. The interns were visibly shaken. This range of vocalization is powered by laryngeal control and precise muscular coordination. They shape airflow into complex syllables. It's not just communication, it's cultural. They use this to inspire, deceive, flirt, and even simulate bird sounds for amusement. Joran leaned back. And they use it for kissing, too, don't they? Professor Vox grimaced. Unfortunately, yes. They share emotional signals and saliva simultaneously. It is both bonding and biotic chaos. She switched the display to a combat clip. A human screamed, spat blood, then bit an attacker. The mouth is an expressive interface, a sound weapon, and a last resort attack method. Respect the mouth, or it will bite. The hollow display shifted to a close-up of the human mouth again, this time zooming in on the strange pink appendage writhing behind the teeth. Professor Vox spoke with theatrical caution. Interns, this is the tongue. A muscular hydrostat, meaning it functions without bones, using pure muscle to contort, extend, and flex. Gasps echoed around the classroom. It is used for speech, food manipulation, cleaning, communication, and most disturbingly, tasting. She brought up a thermal image showing the thousands of taste buds lining the tongue's surface. A side panel displayed a range of flavor categories: sweet, sour, salty, bitter, umami. The tongue detects chemical compounds in consumed material and reports to the brain for approval or rejection. But its flexibility allows humans to also use it for highly detailed actions, flipping food, forming complex phonemes, and even removing particulates from their own skin. A video showed a human child sticking their tongue out and touching their nose. This behavior serves no purpose. It is simply demonstration. Joran was clearly disturbed. Wait, they cleaned their teeth with it too? Yes, Vox nodded. And their cheeks. And sometimes the outer lips. Humans maintain oral hygiene with tools, but in their absence, the tongue assumes the role. Another student asked, how strong is it? Incredibly. It can press food against the roof of the mouth to crush it. And in certain cultural rituals, they use it for expression, seduction, or mockery. A clip played of a teenager sticking out their tongue. They weaponize insolence through facial muscle control, Vox explained. You'll get used to it. Professor Vox zoomed in on the open human mouth, this time focusing on the teeth, white, jagged, and unervingly symmetrical. Now we examine one of the most visually unsettling aspects of the Terran face, the teeth. These are calcified growths, embedded in the jawbones, used primarily for mechanical breakdown of food. But that's just the beginning. She brought up a dental diagram. Humans are heterodonts, meaning they possess multiple types of teeth, incisors for cutting, canines for tearing, premolars and molars for crushing and grinding. A student whispered, why so many shapes? Isn't that overkill? Vox nodded solemnly. It's called omnivory. Humans consume both plants and animals. Their teeth evolved to process a wide range of biological materials, from fibrous roots to dense protein masses. An image appeared of a human eating raw celery. Then it cut to another gnawing on smoked ribs. They sharpen these blades through repetitive use. Some even modify them with metallic coatings or aesthetic shaping. And perhaps most disturbing, they smile with them. The class recoiled. Yes, exposing the full set of teeth is a social gesture. A friendly one. Among their kind, it is interpreted as warmth. Among ours, it would be a death threat. One student raised a frill. They grow back. Yes? Only once. They are diffeodonts, with a temporary child set, then a permanent one. After that, replacements are artificial. They insert synthetic teeth into the jaw by drilling into the bone. A shiver passed through the room. Remember this. Teeth are not weapons until the mouth opens. At that point, it's already too late. Holographic display faded to a muscle-mapped human face, skinless, glistening red fibers twitching and flexing in eerie patterns. The class murmured in synchronized discomfort. Professor Vox adjusted her vocal tone. Beneath the surface of the human face lies a web of over 40 muscles, many of which serve no function in survival. Unless you count expressing every passing emotional impulse as a survival tactic. The musculature flexed on command, a frown, a grin, a raised eyebrow. These muscles allow for smiles, scowls, pouts, glares, smirks, sneers, and a nearly endless range of micro-expressions, tiny twitches that betray internal thought. They claim to have something called a poker face, but it rarely functions correctly. A student clicked nervously. So, they can't control it? Oh, they try, Vox replied. But even when attempting deception, humans leak cues. They raise one brow, tighten their lips, squint their eyes. Emotions like anger, confusion, attraction, and disgust all have corresponding muscular patterns. The hologram demonstrated. These facial twitches are largely involuntary. While they can be trained or masked to a degree, even the most disciplined humans often reveal themselves without meaning to. The class grew still. One brave intern asked, so we can read them? Vox paused. Yes, but so can they. With terrifying precision. Trained humans can detect lies, social discomfort, even hostile intent by observing facial behavior alone. She leaned in, voice lower. This isn't just muscle. It's an emotional broadcast. And if you're not careful, they'll read you first. Professor Vox tapped her pointer against the hollow display, which now showed various humans in rotation, some with long head hair, others bald, and some with facial and body hair in patchy, inconsistent patterns. Now we examine a truly baffling evolutionary trait: hair. She sighed. Keratin-based protein strands that sprout from follicles embedded in the dermis. Functionally ambiguous. A tentacled intern raised a limb. Does it serve any biological purpose? Technically, yes. Originally, hair served to retain heat, protect sensitive areas, and provide tactile feedback. But humans have lost most of their body hair compared to ancestral forms, retaining dense growth only on the scalp, eyebrows, armpits, groin, and strangely, above the upper lip and along the jawline. A few students recoiled at an image labeled beard, culturally significant face bristle. Despite its reduced function, humans place extraordinary cultural importance on hair. They trim it, color it, decorate it, and assign social meaning to its length, shape, and absence. Footage played of humans at a salon, then of another shaving their head for a ceremonial event. Hair also regenerates rapidly and requires maintenance, but inconsistently. Some humans grow hair nearly endlessly, others cease production entirely by midlife. Entire industries are devoted to restoring lost hair or removing unwanted patches. Another student squinted at the slide. They also have eyelashes? For what purpose? Dust deflection, Vox answered dryly. And fluttering. Apparently it's flirtatious. To summarize, hair is biologically inefficient, wildly expressive, and weaponized for identity. In other words, peak human behavior. The holo display now showed a cross-section of the human skull with the brain exposed, pulsing gently. Encased in a shimmering network of nerves and blood vessels, Professor Vox spoke with reverence. Behold, the human brain, a 3-pound bundle of fat, electricity, and sheer chaos. It is the central processing unit of the human organism, protected only by a layer of fluid, thin membranes, and a surprisingly fragile bone shell. She rotated the image slowly. And yet, this lump of neurons commands every breath, memory, movement, and nightmare. A few students leaned forward, stunned. It consists of approximately 86 billion neurons, each capable of firing up to 200 times per second. These signals travel along synaptic pathways at speeds exceeding 400 kilometers per hour. And they do this constantly, even in sleep. Joran squinted. Is that the outer layer? The wrinkled surface? Yes, Vox nodded. That is the cerebral cortex, folded for efficiency, divided into lobes. Each region handles specialized functions: logic, emotion, language, memory, visual processing, motor control. The holo lit up, regions flashing: frontal, parietal, occipital, temporal. But don't be fooled by its complexity, Vox added. It's vulnerable. A blow to the skull, oxygen deprivation, or sudden pressure changes can impair or destroy it. Yet despite this fragility, the brain is resilient. Humans can lose sections of it and still function. A short video played. A man missing part of his frontal lobe solving a puzzle. This is not merely an organ. It is a self-learning biological computer, capable of adaptation, imagination, and perhaps most dangerously, belief. She paused. Do not underestimate it. It is soft, but it runs everything. Professor Vox adjusted the display, now highlighting interconnected neural pathways between the eyes, ears, nose, tongue, skin, and the brain. Each line pulsed with light, a symphony of electrical signals bouncing between organs and gray matter. Interns, we've examined the human sensory systems individually, she began. Now, observe how they converge, seamlessly, constantly, and with astonishing efficiency. The classroom darkened as a simulation played. A human walking through a forest trail, eyes scanning for movement, ears catching the snap of a twig, nostrils flaring, tongue responding to moisture, skin reacting to temperature and texture. This is sensory integration, the process by which the human brain collects input from 5 primary sensory organs and produces a coherent experience of reality. They see, hear, smell, taste, and feel simultaneously, often with subconscious processing. Vox pointed to the thalamus, glowing at the center of the brain model. This relay station filters and directs incoming sensory data, prioritizing threats, remembering patterns, ignoring background stimuli. It is adaptive, filtering out ticking clocks and buzzing lights while highlighting danger, novelty, or food. A few students stared in awe. Joran raised a tentacle. But isn't that computationally overwhelming? Indeed, she replied. Yet they thrive in it. They crave it. In fact, the absence of sensory input causes distress. Sensory deprivation leads to hallucinations, emotional breakdown, even madness. A pause, a heartbeat, a fly buzzed in the simulation, instantly swatted by the human. They are not just reactive creatures. They are aware. This network doesn't just interpret stimuli. It shapes perception. Every human is walking through a custom-built illusion based on their senses and their beliefs. She folded her cilia. That's what makes them unpredictable. The hollow display flickered to life again, this time cycling rapidly through thousands of human faces. Every single one was slightly different. Eye shape, nose width, skin tone, freckles, jawlines, scars, and more. Professor Vox tilted her head slightly. Now we address a baffling quirk of human social intelligence: facial recognition. She paused as the room stared at the overwhelming variety on screen. Despite sharing over 99.9% identical DNA, humans produce an astonishing range of facial variations. And what's more, they can identify and remember thousands of distinct faces, often after a single glance. One of the students clicked in disbelief. But the differences are so subtle. How do they distinguish them? Vox smirked. Through pattern recognition. Even infants show a preference for face-like structures. The human brain dedicates an entire region, the fusiform face area, to tracking, interpreting, and remembering faces. She highlighted that section in the brain, nestled in the temporal lobe. Humans can even detect emotions, intentions, and lies based on the smallest shifts: a twitch of an eyebrow, a tightening of the mouth, a microsecond of widened eyes. A holovid played two nearly identical faces, one smiling, one faking a smile. The class gasped when told which was real. Moreover, Vox continued, they decorate their faces, add pigment, alter hair, even modify features permanently: scars, piercings, paint, and expressive markings. Joran whispered, so they voluntarily increase the chaos. Exactly, she nodded. And they still recognize each other. To a human, a face is not just a body part. It is a signature, a social passport, a battleground of expression. They bond with it, love it, judge it, miss it. She paused as the hollow cycled back to a single face, smiling warmly. And when one is gone, they never forget it. Professor Vox dimmed the lights once more, now showing a montage of human faces, smiling, crying, scowling, laughing, smirking, trembling, all in high definition. Interns, we have arrived at one of the most defining and frankly exhausting features of the human face: emotional expression. She paused to let the wave of discomfort settle in. Human faces are in a constant state of motion. Micro-expressions flicker in response to thought, memory, even internal monologue. Their faces do not merely react, they broadcast. In real time. A time-lapse play of a human watching an emotional video. The changes were subtle, but relentless. Nearly every facial muscle is tied to their limbic system, the seat of emotion. Fear, joy, disgust, surprise, sadness, anger, all of it manifests externally, voluntarily or involuntarily. A student gestured uncertainly. But what advantage does that give them? Isn't that risky? It is, Vox agreed. But it builds trust, vulnerability, empathy. In human society, reading a face is often faster and more reliable than speech. A clip played, a mother recognizing her child in a crowd by nothing but expression. Then another, a lie detected by a twitch in the corner of the mouth. They can lie with words, she said, but their faces often betray them, unless trained. Then came the real kicker: footage of a human laughing during stress, crying from joy, smiling during pain. And sometimes their emotional signals conflict. This, too, is normal. Humans contain contradictions, and their faces reveal them all. Vox looked around. If you wish to understand a human, observe their face. It will tell you things they don't even know yet. the holo display slowly returned to its original image. A single human face, neutral expression, then smiling. Professor Vox let the silence settle over the classroom like a soft neural fog. "So," she began, her voice calm and deliberate, "you now understand why the human face is a source of both fascination and fear." She paced slowly before the holo. "It is the only species known to us that places its most expressive, most fragile, and most socially critical components in the front, with no armor, no exoskeleton, just skin, bone, and muscle arranged for maximum vulnerability." She gestured toward the image. "The eyes can be blinded. The nose can be broken. The mouth can be gagged. And yet, humans lead with this structure in every interaction. They rely on it. They trust it." A pause. The projection shifted to show humans in different social contexts, laughing, crying, arguing, comforting, leading, always facing forward, always showing their faces. This is not just anatomy. It is a strategy. Humans use facial exposure as a social weapon. They provoke empathy, signal dominance, invite trust, warn of danger. Their faces can unite a crowd or silence a room. She turned to the class. And yet, even knowing how exposed it is, they rarely hide it. Even in war, they go helmetless for the sake of identity. Even in diplomacy, they insist on face-to-face meetings. Even in grief, they show everything. The final image faded into darkness. The human face is not just a biological feature. It is a message point one that says, "I see you. I feel. I am not afraid to be known." Professor Vox folded her arms, her voice quiet now. "Study it well. One day, it may be the last thing you see." The room dimmed as Professor Vox summoned a final composite display. A transparent human head layered with flashing systems. Nerves, bones, muscle, senses, skin, and emotion, each flickering in and out like a visual checklist of everything they'd studied. "Well," she began, "if you've made it this far without fainting, vomiting, or filing a transfer request, I commend you. You've survived your first full examination of the human head." She pointed to the floating model. What appears at first to be a soft, poorly armored sensory hub is, in fact, one of the most densely complex, behaviorally loaded, and socially volatile biological structures in the known galaxy. She began her recap, tapping each region as she spoke. The skull, a bone cage for a sentient storm. The eyes, precision optics wired directly to a high-speed processor. The ears, sound intake with a motion sensor built in. The nose, smell, mucus, and memory tied into one odd air tube. The mouth, tool, weapon, speaker, and social gateway. The tongue, muscular multi-tool for flavor, speech, and sass. The teeth, internal bone blades. Not ornamental. Facial muscles, expression through microconvulsions. Hair, a cosmetic protein obsession. The brain, a soft computational marvel with an ego problem. The senses, 5 portals to reality, sometimes conflicting. Facial recognition, they memorize chaos and call it identity. Emotional display, they wear their thoughts on their flesh. She turned from the hologram, facing the class directly. The head is not just a control unit. It is a performance stage, a threat assessment interface, and a social broadcast station. Fragile, exposed, and always active. She narrowed her gaze. Respect the head. Learn from it. And above all, never assume the expression matches the intention. That's where the humans get you. The lights returned. Class dismissed.